So today I'm going to show you a normal workflow for creating some selected load combination in RCDC. Selected load combination means, for example, you are going to design a set of footings in RCDC or Staad Advanced Concrete Designer, but you don't have the stat file. It might happen that your team is not working with the team who is looking after the superstructure. For example, you are the concrete team and your superstructure team dealing with the steel structure like warehouse, factory shed, and so on. So generally this happens when there are two teams or your client has given you only the support reactions to you and asked you to design the footing in RCDC based on those support reactions. So what are the way by which we can deal with this kind of situation? Now, why I have created this video is like in RCDC, please be noted, we can't define any kind of loading inputs. Loading inputs means like information of the magnitude of load, create additional load cases and all. We can't create that. All we can do, we can get them imported from the post-processing file. Now, whatsoever is the support reactions that StatPro has delivered in the post-processing file, these information would be transferred to RCDC, and then support reactions not exact is not the correct word. It's member and forces. This means the column and forces. These information would be transferred to RCDC for designing. So the challenge here is, as I mentioned, that if it might happen that you have got only the Excel spreadsheet like this from your client or from your team who is working on other type of structure, but they don't want to share the stat file. They have just provided you the support reaction in this spreadsheet format. Now, as I mentioned in RCDC, you don't have the option to input these loads in RCDC. So somehow you have to pull the information through stat file only. So how to do that? First of all, these are the support reactions the user has obtained from the post processing of StatPro, and he has provided it to me. Now I have to only work with this Excel spreadsheet. Now, as I can't input in RCDC, so I have to create a stat model and create dummy columns where I can define the loading input so that I will get the similar or the same reactive forces instead. So the idea is I have to mimic a condition so that instead I will get the same support reaction and then I can pull it in RCDC. Okay. Now for this I have, let me open a stat file. Okay. So this is a very simple model, a cantilever column. This is a dummy column. So you can take a dummy rectangular shape like 250 millimeter by 250 millimeter, and you just create it by assigning a support at the base, fixed support at the base. Now, please be noted, I have stressed on some phrase like RCDC won't read the support reaction, it reads the member and forces. That means in some cases it is same, means if the column is continuous and the bottom of the column is being assigned with the support, then of course the member and forces would be same as the support reactions, means the column and forces. But here we don't have any loading that has already been defined. What do we have to define? We have to apply the load so that the reaction would be same as what we have obtained or what we have been provided in the Excel spreadsheet. So very intuitively, you might wonder like, okay, in this column base, I can directly assign the support, and on the support, I can directly define the loading and it will give the reactive forces and we can take it back to the RCTC. But please be noted that when we are applying any loading at this supports, then there would be only reaction, but there won't be any member and forces. Please be noted because the loading is directly applied on the support. So how STAT would calculate the member and forces. But again, as I mentioned, RCDC can only read the member and forces for designing the footing. It can't read the support reaction. This is how the program has been written. This is not a fallacy or any limitation. So we need to apply the loading in such a way so that the member and forces would be having the same forces that we have been provided with. So these are all the reactive forces. So what I have to do, I have to apply the loading whose magnitude is inverse to this reactive forces. So what we have done here is this was, you can see that if I show you, if I slightly, uh, let me show by this. You can see I have just zoomed in. You can see there are two different members. This that actually I have created these two members. I've taken a very small distance just above the support and inserted a node and fragmented this column. The purpose is to apply the nodal load at the vicinity to the support. I could have applied it here directly at the support, but here I won't get the member and forces for this column because loads are directly transferred to the support. But I have to pass the load through some members so that I can get the member and forces. There's the reason I have taken at the vicinity. Why at the vicinity? I could have applied it at the very top. But what will happen if I apply the load at very top? You can understand that this is the total length, and for the lateral load especially. If I provide the lateral load value, I was expecting like, okay, whatever the load I am applying it here, I will get the same amount of reactive forces in the opposite directions. But what happens due to this lateral force, whenever you are applying it, you are getting the opposite uh, reactions in the translational direction. But due to this lateral force, there would be some movement due to this lever arm action. And this moment is not expected because we want to take only the moment that has been provided to us. So we don't want to create some additional moment out of those lateral loading. So that's the reason we have taken a very small amount of distance so that the lever arm would be very minuscule and still there would be some movement, but it is very negligible. So it doesn't affect my entire loading, actual loading. So that's the reason I have created three load cases. For example, you can have multiple load cases. For example, I have been provided with first load case is earthquake, second is again earthquake, and fifth is dead load, sixth is live load, and also wind loads, and so on. You can create by the similar procedure. So I've taken only dead load, live load, and earthquake load, and provided the nodal load with the value opposite to the reactive forces. Now here you can see the reactive forces are shown with some negative sign. This is negative, then positive, positive. So whatsoever is the value, you need to just invert it and apply it in this stat model. So it was minus 15.4. So here I have provided the loading as plus 15.4. Similar way, all the values that I have provided is the values that we have provided in all the boxes are absolutely inverse of the actual reactive value. You can see minus 102 plus 0.884. So similarly, I have inverted it and made it plus 102, then minus 0.88. So I have applied it exactly at this created node, which is at the vicinity of the support. Okay, so then I have created the combinations, load combinations, just to dummy load combinations I have created. These load combinations I have created for designing. Also, as you understand that for footing design, you need two types of combos, like one for strength and one for the service condition, like for sizing and all. Either you can create the load combination for sizing here. For sizing in general, it is taken as unity, or you can exclude it. You can create it in RCDC also. Please be noted, you can create the same load combination also in RCDC, but I'm assuming that there is a scenario like, okay, you want to create all the load combos within Staad and want to call them in RCDC, then what would be the workflow? So here I have only taken the load combination for designing, that is for strength. I have amplified it by 1.5 in first one, then 1.2, the standard way. And I have not created the service load condition. I will create it in RCDC so that you can understand both the approaches. Okay, so let's perform the analysis. So analysis is done. And if you see that member, this is a small member. I will take. I'm not concerned with the top one. Top one is just the dummy one. Okay. Or you can rather than in the modeling phase, if you create a very if you create a column with a very negligible height, that's also fine. Rather than creating the whole length and splitting them, you can create a column itself with a very negligible height and directly apply the loading at the tip without fragmenting it. Okay, now if I go to the post-processing file and if I go to like beam and forces, you can see these are the member forces. Okay, one is positive, one is negative. That's to maintain the equilibrium. So the idea is all the loading that we have got from my client, the support reaction, I have somehow replicated it in such a way that I will get a similar reactive forces as a member and forces. You can see 102, that is the same thing that I have been provided with. You can see. Fine. Now let's go to Advanced Concrete Designer. Okay, now give some name. I'm just putting some phony name. Select the design codes. I'm selecting here the Indian design code with the detailing, ductility detailing of 13920. Now here, as I have already exported it from a stat file, so the name of the stat file has already been mentioned. And please be noted that program only reads the post-processing or the analysis data from either stat, ETABS, or RAM structural system. So as it's my job is for designing the footing, so I will select the design element as footing, create it. Okay. Now I won't cover the all the other aspects of RCDC because this is just to show the workflow for this kind of scenario. Just to give you an idea, like these are the general setting where you can control all those setting for design like thickness, clear cover, grade of steel, minimum, maximum depth, and so on. Just I'm keeping all of them as a default. There is also reinforcement setting and all. But the main idea here is to see how to deal with the load cases. That's the most important part. So here you need to map the loading type with the load cases that we have defined it in STAD so that RCDC can also understand that the load cases nomenclature that we have defined, what are they meant for. This is for dead load. This is for live load. Just select all of them. Either you can click on this or you can like this. Okay. Now click on OK. Now immediately you can see a new dialog box that will appear here. Uh, there you have two different options. One is add from template and add from analysis. Very interestingly, add from template means the RCDC itself has the load combination generator, that is the auto load combination generator based on the different factors defined by the respective code. So we have used the Indian code, so it will create all the load combination and assign all the factors as per the codal guidelines. So I could select like regular structure. If I select like this, it will select all the you know combos like this. These are the load combination that RCDC has created. But as I mentioned, I want to take the load combination that has been created within Stat Pro and I want to call it here. So here I will do like add from analysis. Okay, it will override just. So these are the load combination that we have created. Just recall what we have done in Stat. Dead load, live load 1.5, dead load, live load, EQ load 1.2. So this is for designing, that is the strength limit state, and this is for the service limit state, that is for sizing, initial sizing and all. So for sizing in general, the normal practice, we are keeping the factor as unity. So if you do it from add from analysis, then of course it will take as 1.5 because it can't understand that, okay, it's for sizing. Whatsoever load factor that we have defined in stat, it will simply import it. Okay, but had it been the case that you would have created the serviceability load combos, for example, combination number 7th or 8th, you could have checked off, and if there would have been serviceability combos, it would have also shown with the unity factor, and you could have retained them. But here we didn't do. So what we'll do here, we don't want this amplified value. You want it as a unity. So we will do the regular way. Either you can come here and make it like 1 and 1 and 1, but rather than doing that, it's the straightforward way is go to this template. It will automatically understand that, okay, it's for sizing. It will assign all the factor as unity. You can check them out or check them in depending on your requirement and create on OK. Now I can fire the design. Designing has been done. Now, if I go to the view, member force, because a single footing that I have taken, display. Now you can see this is the member and forces based on which the footing design is done. Now this member and forces like again 102.04, 0.15 is the moment, shear. These all values, if you compare with my actual Excel file, it's the same thing. Okay. Fifth one is 196, 196. Then we have like sixth one is 109. Okay. So idea is I have somehow uh, mimic the same condition instead to get the similar kind of reactive forces so that we can use it for designing in RCDC when we don't have the actual stat file. Okay. So this is how it has considered. And if you go to the reporting, then if you want to see the design calculation and all, you can see the actual design calculation and all the different kinds of considerations. Let's see. So you can go further and see how it has designed. So here you can see these are the amplified value because it's like dead load, live load times 1.5. So these values has been taken and accordingly it has performed the design. Okay, so this is a normal workflow. If you have this kind of situation where you don't have the actual stat model, but your client or your colleague has provided you the Excel file. Now you might be wondering, like sometimes it might be cumbersome, like to manually see and provide the value in stat by doing the manual inputs. I understand. What you can do, either you can create a VVM macro by which you can convert them into the required just a moment, let me open the model first. Okay, now you can create a VVM macro by which you can automatically create inputs like this. First of all, you can do like this, what I have done directly, or you can within Stat Pro, within Excel, you can create another sheet like this, and first of all you can multiply all of them with -1 times these values so that I'm converting the reactive into the active force, and you can make it like this, then just see the format that stat understands. and just create the format here just like this. If it is like fx, give a name like fx. Same way for fy, you can again create it from here like this, -1 times fy. Just a small example of the workflow. Now, once you have done it and you have maintained the exact format, you can just check with this existing format how Staad recognizes it. Joint load, just give it joint load one. So if your format is ready before you, you can copy it like this and paste it in the loading page. Okay. You might be wondering like, what about the title? You have to create it within the Excel and create it and copy the entire thing. So these are two approaches. If you could create a macro, then everything would be very much simplified and very much faster. Everything would be automated. But again, you can do it without doing the macro. Also, you can do it in the Excel. I'll see that if I can create a macro if I get some time, because this is a normal procedure most of our users do, and it's a very useful approach. And normally our user practice this kind of approaches, and it really works. Okay, that's all.